Hey guys, it's Mr. Stark again, and I'm here to show you another video on the forward reverse contactor. And this time it's actually inside the motor enclosure. If you can, see the wiring that's going on in there. I'm going to show you what it looks like with the cover on. This would be the enclosure with the cover on. Right now the cover is off, and I've integrated another cool feature into this forward reverse like I talked about in the last video. In this one, we have two off delay timers, and you're going to learn about what these off delays mean. I also have a couple of control relays that are acting like a trigger switch in order for this circuit to work. So when you see the video on just the off timer, you'll understand it needs a trigger or a closure, if you will, in order for it to work. And I'm using a simple control relay for that function. So the idea of this circuit is to hit the forward and then hit the stop and then immediately go to hit reverse, and it won't work until the timer times out. So right now I'm going to hit the forward button and you're going to see the contactor pull in. So you can see that pulling in. The motor is running. You could probably hear it running. I left the taps out because we're going to talk about motor taps in a minute and how to tap low voltage and high voltage. So right now the motor is running in forward. I have a control relay pulled in. When I hit the stop button, I've got these set for somewhere in the 10-15 second range, so we're going to have to wait a few seconds for this to work. I'm going to hit stop. You hear that the forward dropped out. I'm going to start hitting reverse right now, and you see it's not going to work. So I'm going to continue hitting reverse until this timer times out, and there it goes. So now that worked. It allowed the motor to come to a complete stop. I'm going to hit stop again so we can do the same thing in forward. Notice I'm hitting forward, and we're going to continue waiting for this timer to time out. I'm going to continue hitting forward. We'll wait here, because that's what I'm going to be doing in the lab, is waiting. There it goes. So now the forward's pulled in. And once again, we'll turn the circuit off. What's the point of all this? The main point of all this, obviously, is to make sure that the motor comes to a complete stop before you're allowed to hit or change the rotation of the motor, so that you don't damage the motor through, that quick starting and stopping that we talked about on a previous video. I'm going to hit forward again, just because it's fun hitting a circuit that works. Typically down here we put these single pole switches across this for the PLCs. So when you get to lab, you'll see another video on this. We're putting single pole switches to simulate our inputs on the PLC. Obviously right now we're not using the PLC, we're using relays. But one of the things we like to simulate is the function of an overload. And if I hit that switch, I just opened up or simulated an overload. You notice that my motor stopped running. And I'd have to put that back to its normal position, and we're gonna, obviously that switch is upside down, it's kind of an accident. We'll hit forward and we get the same function. Remember, we can't hit reverse in the process of the motor running. That's the whole idea, we're trying to protect that. There's the interlock. You have to hit stop and then you wait for the timer to time out before you can hit reverse. So pretty cool circuit. You can see that the normal instance, the wiring is done fairly neatly. We've got other functions in here, the wiring nicely done. And we're using fire alarm wire in this case because it's easy to use, it's easy to strip. We've got a small signal on this, so there's no harm in this. But in the real world, you'd probably be using 14 gauge stranded wire for all your control circuit, and most of which would be red in color. But because we don't like to waste anything, we're going to use up this fire alarm cable that would have normally gone in the garbage after a lab. It's a perfect use for motor controls. So hopefully you got something out of this, and we'll see you at the next video.